Hello everyone. Today let me take the properties and synthesis of furan and then thiophene. Okay. Now this is the molecular formula of furan. You can see here it has got pentagon shape. Alright. It has got 4 CH groups. You can see here CH, 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 CH and 2 double bonds over here, and then one edge or one corner occupied by oxygen atom which has got 2 lone pair of electrons. Okay. So this is what furan, or IUPAC name is oxole. Okay. Now what are the general methods of synthesis? Okay. First method is a dry distillation of mucic acid. So this is mucic acid. Okay. So it has got 2 carboxyl groups and 4 secondary alcoholic groups are present. Alright. So this compound on dry distillation, what happens? 1 carbon dioxide molecule is eliminated, 3 water molecules are eliminated to give what? Furic acid. So this is the molecular formula furic acid. Okay. So this is carboxyl group. This on heating eliminates the molecule of carbon dioxide. You can see here carbon dioxide molecule is eliminated. Okay. So that H will combine with this carbon atom here, forming what? Furan. That means CH, 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 CH and one oxygen atom. Alright. So that's how you get what? Furan. Okay. Now oxidation of furic acid. Now how it is? Furic acid is obtained from 4-fural. Alright, what is 4-fural? It is nothing but one, the molecule of this oxole, okay, this molecule or furan, and then aldehyde group. Alright. So this on oxidation with potassium dichromate, acidified potassium dichromate. So here there is a mistake, it is not dry distillation, it is oxidation in the presence of acidified potassium dichromate. Okay, oxidation takes place. So what happens during oxidation of aldehyde group? Always acid is formed, right? So CHO group undergoes oxidation to give what? Carboxylic acid, that's all. So or in other words, 4-fural is oxidized to furic acid. Okay. This on heating eliminates the molecule of carbon dioxide. You can see here this carbon dioxide is eliminated, so that H will combine with the carbon to give what? Furan. Okay. Now third method is oxidation of dialdehyde. Okay. Now which dialdehyde is used? Succinic dialdehyde. Okay. So succinic dialdehyde is used. This is the molecular formula CH2, CH2, CHO and then CHO. Okay. Now this exists in another form also, which is the other form of succinic dialdehyde with the secondary alcoholic groups. Okay. So which is the secondary alcoholic group? CHOH, CHOH. How do you get this? Another form. This carbon hydrogen bond will break here. Okay. This H will come over here and attach. The double bond will break. Okay. So that you get CHOH. Similarly, CH bond undergoes cleavage. Okay. This double bond also cleavage. Therefore, you get what? CHOH. Okay. Or in other words, it is just rearrangement of what? This formula or this compound, succinic dialdehyde. Okay. Now this on heating with phosphorus pentoxide, it is not trioxide, it should be pentoxide. Okay. Phosphorus pentoxide. Alright. Elimination of a molecule of water takes place to give what? Furan. Okay. So that's how you get what? Furan. Alright. Now what are the chemical properties or reactions of one? Furan? Okay. First one is a Diaz-Sade reaction. So what is Diaz-Sade reaction? It is the reaction between furan and malic anhydride. Okay, to give an adduct. Adduct is nothing but addition product formed. Okay. So furan combines with the malic anhydride. Okay, you can see here this double bond, this pi electrons will undergo one, form new bond with the H. This pi bond will break or double bond will break, single bond is formed and another new bond is created or generated between this molecule. Okay, here. And then this double bond undergo cleavage, pi electron gets shifted over here, that's how you get double bond here. Okay. This pi bond cleavage and pi electrons get shifted over here, new single bond is formed. That's how you get one adduct. Okay. So adduct is formed. Another reaction or chemical property is reduction. Okay. What do you mean by reduction? Hydrogenation in the presence of palladium. Okay. Palladium. So when hydrogen gases pass through furan over heated palladium, you get what? Tetrahydrofuran. How do you get tetrahydrofuran? So this double bond once again here undergo cleavage, single bond is formed and hydrogen adds up forming CH2. Okay. All the 4 corners you have CH2, 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 CH2. Okay. That is nothing but tetrahydrofuran. Okay. Now next let us say electrophilic substitution. Okay, electrophilic substitution takes place in two ways: attack at position 3 and attack at position 2. Okay, where is the third position? This is third. Okay, second position here. Okay, so by shifting of electrons, okay, in two ways you will have two types of attacks. You can see here attack at position 3 how it takes place. Okay, now in order for electrophilic substitution you should have negative center, right? Why negative center? Electrophile is positively charged. Okay, how third position gets negative center? This pi electron gets shifted over here, so that this carbon is negatively charged. Okay, since this become negatively charged, electrophile will attack. Okay, so that you get here bond. Okay, new bond is formed here. H was already there actually, but we have not written here. Okay, I have not written here. H was already there, so CH and then E. Okay, now when these electrons get shifted over here, okay, this becomes positively charged. This carbon becomes positively charged. Okay, so electrons, that is lone pair of electrons from this section get shifted over here, forming double bond. Okay, that's how you get double bond here. Since a lone pair of electron gets shifted in between oxygen and carbon, this oxygen is positively charged. Alright, therefore you have positive. So this exists a resonance with another form, which is the another form resonance. This bond will break, carbon hydrogen bond will break, these electrons will get shifted over here. Okay, generating new double bond. You can see here generating new double bond. Once the double bond is formed, this positive charge gets neutralized. Okay, and positive gets charge neutralized. Okay, these electrons have come back here, therefore you have lone pair of electrons here. Okay, so lone pair as it is. So this is known as a 3 substituted product or third substituted product. Okay, now attack at position 2. How attack at position 2 keep taking place? Alright, now second position must be now negative center. Okay, in order to the electrophilic attack at the second position. Okay, how second position becomes negative center? These electrons get shifted over here. Okay, so that this becomes positive charge. Can you see here? This becomes positive charge. Okay, since this carbon become negative, electrophile attack, form a new bond. Okay, CH was already there, so new bond. So this is positive now. Since this is positive, this will pull the electrons of the neighboring pi electrons, or this bond will break. Okay, so a new bond, double bond will be formed here. This center becomes positively charged. Okay, can you see here? This becomes positive charge. Now once this becomes positive charge, this will pull the electrons, lone pair of electrons here, which are in the close neighborhood. Okay, so lone pair of electrons are pulled here, therefore new double bond has been created, therefore this oxygen becomes positively charged. Okay, now once this becomes positive charged, okay, this exists in another product, that means this will pull the electrons towards itself. Okay, this becomes positively charged, therefore these pi electrons get shifted over here. Okay, and when this pi electron gets shifted over here, this becomes positively charged, therefore this bond will break, CH bond will break. Okay, and these electrons get shifted over here, giving bond, new double bond here. Okay, therefore new double bond is created. Here no H, because elimination of H plus taking place. Alright, here lone pair as it is. Alright, so this is known as second substituted product. Okay, now next let us say electrophilic substitution reactions in furane, thiophene and pyro. Now all the three follow same mechanism. Okay, direct nitration and sulfonation leads to resin formation. Okay, resin like products are formed if direct nitration or sulfonation is carried out. Okay, therefore in these compounds indirect nitration and sulfonations are followed. Okay, all these compounds direct nitration or sulfonation is not possible. Why? Because resin like products are formed. Okay, therefore always indirect nitration or sulfonation is done. Okay, now let us see how indirectly nitration or sulfonation is done. Indirect nitration, in addition to nitric acid, you can see here, in addition to nitric acid, acetic anhydride is added and then heated. You can see the temperature 283 Kelvin. Okay, so heated. So furane, when it is heated with nitric acid in the presence of acetic anhydride to give what? 2-nitrofurane. Okay, you get 2-nitrofurane and then acetic acid. Okay, so this bond will break here, forming acetic acid and then 2-nitrofurane. This is known as indirect nitration. Okay, now how indirect sulfonation is done? Indirect sulfonation is done by passing sulfur trioxide in the presence of pyridine heated to 373 Kelvin. Okay, so furane reacts with sulfur trioxide, okay, in the presence of pyridine, temperature 373 Kelvin to give furane to sulfonic acid. This is known as indirect sulfonation. Alright. Now next is halogenation. How is halogenation is done? Furan on chlorination at temperature 233 Kelvin gives a mixture of 2-chlorofuran and then 2,5-dichlorofuran. You can see here second place chlorine and here second place and fifth place. Okay, so it gives a mixture of 2-chloro and 2,5-dichlorofuran is obtained. This is known as halogenation. Okay. Next is Friedel-Crafts acylation. What is acylation? Reaction with acetyl chloride, right, in the presence of stannic chloride as catalyst. What is the formula of stannic chloride? SnCl4. Okay, furan reacts with acetyl chloride in the presence of stannic chloride to give 2-acetyl furan. That means second place acetyl group is introduced. Okay, which is the acetyl group? CH3CO group. So you get 2-acetyl furan and the reaction is called Friedel-Crafts acylation. Okay. Now next is mercuration. Mercuration is nothing but heating with mercury chloride in the presence of sodium acetate. Okay. Furan when heated with mercury chloride in the presence of sodium acetate to give 2-chloro-mercury-furan. Okay. So 2-chloro-mercury-furan is obtained. Alright. Next is Gutter-Manon reaction. Okay. Gutter-Manon reaction consists of two steps. Okay. What is the first step? Reaction with HCl and HCl. Okay. In the presence of aluminum chloride, you get NH double bond CHCl. This is the first step. Second step is hydrolysis. Okay, so this will combine with the furan. Okay, this will combine with furan, and then next on hydrolysis gives what? Furfural. Okay, now furan combines with the NH double bond CHCl, that is the product formed by the reaction of HCl and HCN in the presence of aluminum chloride to give an addition compound or a salt is formed, CH double bond NH2 plus Cl minus. Okay, this on hydrolysis gives what? Furfural. Alright, this reaction is known as Gutter-Manon reaction. Okay, next reaction is N-butyl lithium. Okay, that means normal butyl lithium. Furan reacts with the normal butyl lithium. So this is butyl group and lithium, normal butyl lithium in the presence of ether. Ether is the solvent. Okay, to give 2 lithium furan. You can see here second place lithium is introduced or substituted. So this is known as 2 lithium furan. Okay, and then normal butane. So you get a alkane also along with this product. Okay, now 2 lithium furan on reaction with carbon dioxide and HCl. Okay, so it reacts with carbon dioxide HCl to give what? Furic acid. Okay, furic acid is obtained. Next is thiophene. What is the formula of thiophene? This is the molecular formula: CH, 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 CH and sulfur. Okay, sulfur is present with the 2 lone pair of electrons. Okay, now how it is synthesized? First one is from acetylene. Okay, acetylene will react with hydrogen sulfide. Okay, acetylene will combine with hydrogen sulfide in the presence of aluminum chloride. Okay, heated in a red hot tube. When it is heated in a red hot tube, we get one thiophene. Okay, you can see here triple bond will break here, triple bond break. Okay, so that these electrons get shifted over here, forming a single bond. Okay, with the sulfur. All right, and this also single bond. Okay, single bond is generated. So you have one the thiophene. Okay, thiophene and then plus H2. This hydrogen, 2 hydrogen atom will combine to form one hydrogen. Okay, that's how you get thiophene. Next, from normal butane. Normal butane you can write it in this way also. What is the formula? CH3, CH2, CH2, CH3. Okay, normal butane reacts with the sulfur. Okay, that means heated sulfur. Temperature is 923 Kelvin. Okay, heated to this temperature, you get what? Thiophene. Alright, and then hydrogen sulfide. So thiophene and hydrogen sulfide is formed. This is another method of synthesis of what? Thiophene. Okay. From sodium succinate. From sodium succinate also you can get what? Thiophene. How it is obtained? Sodium succinate is this compound. Okay, sodium salt of succinic acid. COONA, CH2CH2, COONA. Okay. This reacts with P2S3, okay, phosphorus trisulfide. This is phosphorus trisulfide to give one thiophene. This is the product form. Okay. Now what are the reactions? Thiophene on hydrogenation in the presence of palladium to give a tetrahydrothiophene. This is similar to one previous reaction. Okay, the reaction of what? Furan. Same way thiophene also reacts, giving one tetrahydrothiophene. Okay. Next reaction with the nickel. Nickel is Raney nickel. Okay. So Raney nickel. Now what is Raney nickel? Raney nickel is nothing but finely grinded solid compound, mostly nickel, derived from nickel aluminum alloy. Okay. So Raney nickel hydrogenation, normal butane is obtained, and then nickel sulfide. Okay, nickel sulfide. Next, electrophilic substitution. So electrophilic substitution, under that nitration. So similar to furan, here also indirect nitration. You can see here acetic anhydride heated to 283 Kelvin, thiophene on heating with nitric acid in the presence of acetic anhydride, giving one 2-nitro thiophene. Okay, and then acetic acid. Alright. Here sulfonation is warming with one sulfuric acid. Okay, sulfonation is done just by warming with sulfuric acid. We get 2-thiophene sulfonic acid. Okay. Now next is sulfonation. Okay, sulfonation is already completed. Okay, after sulfonation, chlorination. This should be chlorination. Okay. Now thiophene on chlorination at temperature 243 Kelvin. Okay, to give a mixture of the 2-chlorothiophene and 2,5-dichlorothiophene. Okay, second place chlorine, this is 2 and then 5-dichlorothiophene. Okay, this is known as what? Halogenation or chlorination. It is not sulfonation, it is halogenation or chlorination. Okay, next Friedel-Crafts acylation. Thiophene on treating with the acetic anhydride in the presence of phosphoric acid, we get one 2-acetyl thiophene. This is acetyl group, 2-acetyl thiophene and then acetic acid. Okay, so this reaction is known as Friedel-Crafts acylation. Alright. Now next is mercuration. Mercuration is the reaction between thiophene and mercury chloride in the presence of sodium acetate. Okay, what you get? 2-chloro-mercury thiophene. Okay, this is also similar to one furan reaction. Reaction with the normal butyl lithium. Okay, so thiophene reacts with normal butyl lithium in the presence of ether solvent to give one 2-lithium thiophene. Okay, this bond will break here, and from here H will combine here, giving what? Normal butane. Okay, CH3, CH2, CH2, CH3. So you get normal butane. Next is chloromethylation. Chloromethylation is the reaction between thiophene, formaldehyde and HCl. Okay, thiophene reacts with formaldehyde, HCl, we get one 2-chloromethyl thiophene. Okay, 2-chloromethyl thiophene. Alright, now I will stop at this stage. Okay, please go through all the slides. Any difficulty, please contact me. Alright, thank you.